Today I'm going to talk you through an entire Chemistry Paper 1 for GCSE Combined Science. Question 1. This question is about carbon dioxide. Carbon dioxide is soluble in water and forms an acidic solution. Which ion makes the solution acidic? Well, you need to remember here that hydrogen ions make acids acids, so you could put H+, or you could write hydrogen ions. Name an indicator that could be used to test if the solution is acidic and give the result of the test. So let's go for the obvious one. We'll go for universal indicator solution. And if it's an acid, you could have either red or orange or yellow because they're all acidic pHs. We're then shown a graph of the mass of carbon dioxide dissolved in water at different temperatures, and we can see as the temperature increases, less carbon dioxide will dissolve in it. So what can we say here? How does the solubility of carbon dioxide change as the temperature increases? Well, as the temperature increases, the solubility decreases because it's a downward sloping graph. This one's quite a tricky question that a lot of people got wrong at the time. Carbon dioxide dissolves in water to form an acidic solution. How does the pH of the solution change as the temperature increases? Well, as the temperature increases, less carbon dioxide will dissolve, and it's the carbon dioxide making it acidic. So it's becoming less acid. So that means it's going nearer towards neutral, so the pH is increasing from 1 or 2 up towards 7. So the pH increases. Then it says calcium carbonate reacts with hydrochloric acid to produce carbon dioxide, and it gives us an equation. What is the state symbol X in the equation? Well, we're looking for the state symbol of H2O, which is water. Water is a liquid, so it gets the state symbol L. The question says figure 2 shows equipment a student used for an investigation. So we've got a measuring cylinder, conical flask, a gas syringe and a balance. And the question asks, the student investigated the volume of carbon dioxide produced when different masses of calcium carbonate react with hydrochloric acid. Describe a method the student could use. So at this point, pause the video, have a go yourself on some scrap paper, then check back in with the video to see if you've missed anything. So here's one possible method. You'll notice I'm not writing out an equipment list to start with. I'm just mentioning the equipment as I go along, and I'm also being specific about the amounts of chemicals that I use. So start off by using the measuring cylinder to measure out 50 centimeters cubed of hydrochloric acid into the flask. Any sensible amount on the measuring cylinder would be okay, like 100 cm cubed or 25 cm cubed. Then I would measure 1 gram of calcium carbonate using the balance and add it to the acid. Immediately connect the gas syringe to the flask and start the stopwatch. After 30 seconds, record the volume of carbon dioxide produced and repeat 3 times for 1 gram of calcium carbonate. Discard anomalies and calculate a mean. And then I would repeat the whole process with 2 grams, 3 grams, 4 grams and 5 grams of calcium carbonate. So I've remembered to say repeat it 3 times for each mass of calcium carbonate, and then I've remembered to say repeat the whole thing for different masses of calcium carbonate. Question 2. Lithium hydroxide reacts with sulfuric acid to produce lithium sulfate, and it gives you an equation. What type of reaction is this? Well, we need to spot that lithium hydroxide is an alkali, and it's telling us we've got sulfuric acid. So an alkali and an acid is a neutralization reaction. They would also allow exothermic because neutralization reactions are normally exothermic. Question 2.2. Calculate the relative formula mass of sulfuric acid. Now you don't even need to look up the mass numbers because it's giving you the relative atomic masses here. So you don't need to confer with the periodic table. Now we've got 2 hydrogen atoms. Each one of those has a relative atomic mass of 1. So 1 plus 1 for the hydrogens. The sulfur has a relative atomic mass of 32. And the oxygen atoms each have an atomic mass of 16, and there's 4 of them. So we need to add in 4 lots of 16, and when we do that it comes to 98. Calculate the percentage by mass of oxygen in lithium sulfate. So we want to know how much of it is oxygen compared to the whole formula. So the oxygen part, we need to spot that there's 4 oxygens in the formula. So that's going to be 4 times 16, which is 64. The whole formula, lithium sulfate, is 110. So we want to know what is the percentage, 64 out of 110. So we do 64, the small number, divided by the larger number, times 100 to get it as a percentage, and that's 58.18%. But we also need to spot the questions asking for it in 2 significant figures. So we've got 58 is the 2 figures, and then we need to know, do we round it up? Is the next number 5 or higher? In this case it's not, so it stays as an 8. So 58 is the answer. A solution of lithium sulfate contains 0.3 grams of lithium sulfate in 25 centimeters cubed. Calculate the concentration of lithium sulfate in grams per dm cubed. So we need to remember the equation for working out the concentration. Concentration equals the mass of the solute in grams divided by the volume of the solvent in dm cubed. So we need to spot that this is in cm cubed, and to change from cm cubed to dm cubed you divide by 1000. So that becomes 0.025 dm cubed. So we've divided 25 by 1000. So now we've got that in dm cubed, we've got the mass, which is 0.30 grams, divided by the volume in dm cubed, which is 0.025 dm cubed, and that comes to 12. If the units weren't given, we'd be able to work them out because we've got grams slash dm cubed. This question's all about sodium. Sodium is in group 1 of the periodic table, and sodium reacts with oxygen to produce sodium oxide. And we're first of all asked to balance this equation. Well, when we're balancing equations, remember we can't mess with these small numbers. All we can do is put a large number in front of the formulas. And it's prompting us to put a number here or here if we need to. So let's list what we've got to start with. We've got 1 Na on the left, 2 oxygens on the left, 2 Nas on the right, and only 1 oxygen on the right. So it doesn't matter where we start. Let's start, for example, with the Na. We've got 2 on this side, we've only got 1 here. So we put a big multiplying number here to get 2 Nas on this side. I'm not saying that's right to start with, but that's where we're going to start. We've got 2 oxygens on this side and only 1 on this side. Now we can't mess with the small numbers, we can't just put a little 2 there. All we can do is put a large number here which multiplies the whole formula. So now we've got 4 Nas because we did have 2, but we've now got 2 oxygens. So we've sorted out the oxygens, they're balanced on each side, but in doing that we've messed up the sodiums. We've now got 4 on this side and only 2 over here. So we'll change that to a 4, and now we've got 4 Nas on here. We do a last check, 4 Nas, 4 Nas, 2 Os, 2 Os. The next question says, explain what happens to sodium atoms and oxygen atoms when sodium reacts with oxygen to produce sodium oxide. Answer in terms of electrons. So the best tip I can give you here is to draw an atom of each. So sodium's got 11 electrons, we'll put 2 on the first shell, 8 on the next, then that one's full, and that leaves 1 on the outer shell. Oxygen has got 8 electrons altogether, 2 on the first shell, 6 on the next shell. So now this makes it a much easier question because we're going to describe what each atom needs to do to be stable. So we're going to say the sodium atom loses 1 electron to be stable with a full outer shell. It's worth saying what type of ion it turns into as well. Sodium's in group 1, they all make 1 plus ions, so we're going to add here, it forms Na plus. Then we're going to do the same thing for oxygen. We can see oxygen needs 2 more electrons, so we're going to say oxygen atom gains 2 electrons to get a full outer shell, and because it's gaining 2 extra negative particles, it forms O2 minus ions. So we've said what each of the atoms do to become stable, whether they lose or gain electrons, how many they lose or gain, and what ions they turn into. The last point that not many people get is for explaining why we need 2 sodium atoms for every 1 oxygen. And this is the reason. Sodium only needs to give away 1 electron to oxygen. So this sodium would now become stable, but oxygen isn't stable yet as it needs another electron. It can't take it from this sodium because it's already stable once it's given away 1 electron. So we need to have another sodium atom that also needs to lose an electron so that it can give that other electron to oxygen, so that oxygen then has a full outer shell. So the way we're going to word that in our answer is that 2 Na atoms each give 1 electron to 1 oxygen atom. Question 3.3. Sodium burns in a jar of oxygen. Give 2 observations during the reaction where you're expected to know the flame colours of the alkali metals, and sodium burns with a yellow flame. So first of all, we could say you would see the yellow flame, and alkali metals react with oxygen to form oxides, which are white powders. So you would either see a white powder, which would be sodium oxide, or you might see it as white smoke. Either of these is a good answer. Describe 2 differences in the observations if potassium is used instead of sodium. So potassium is lower down group 1, and you need to remember that as you go down group 1 they become more reactive. So first of all we can say it burns faster, or you could say it's a more vigorous reaction, taking account of it being more reactive. And the other thing we could say is instead of it being a yellow flame, this time for potassium it would be a lilac flame. The other one you can be asked about is lithium, and that would burn with a red flame. Question 4. Group 7 elements are known as the halogens. All atoms of group 7 contain protons, neutrons and electrons. What is the order of discovery of the proton, neutron and electron? So the first one to be discovered was the electron, discovered by J.J. Thomson when he came up with his plum pudding model of the atom. So that means these 2 answers are definitely incorrect, so we can get rid of those. Next, Rutherford came up with the idea of the nuclear model with the positive charge, in other words protons in the nucleus, and then finally neutrons were discovered by James Chadwick. So this is the answer that you need. If you can't remember all those different models of the atom, I'll put a link up here now to one of my other videos where I go through them all. This question is a straightforward maths question. Using this information, calculate how many times heavier a proton is than an electron. So if we have the mass of a proton and divide it by the mass of an electron, then the answer we get to the nearest whole number is 1837. A bromine atom can be represented like this. What is the number of neutrons? You need to remember to find the number of neutrons, you do the mass number, take away the atomic number. So that's 81, take away 35, which is 46. What is the number of electrons in a bromide ion? Well, there's 35 electrons in a bromine atom, but you should know that all the halogens in group 7 need to gain one more electron to get a full outer shell and be stable. So when it does that and turns into an ion, it gains an electron. So instead of it having 35 electrons, it would have 36 electrons. Chlorine has 2 isotopes. Table 2 shows the percentage abundance of the 2 isotopes of chlorine. Use this information to calculate the relative atomic mass of chlorine. So we've got chlorine 35 and chlorine 37. So the way we do this is we do 75.77%. So 75.77 divided by 100 times 35. And that comes to 26.5195. We do the same for chlorine 37. We've got 24.23% of that. So 24.23 divided by 100 times 37, and that comes to 8.9651, and then we simply add the two numbers together and we get 35.4846, and it's asking for it to 2 decimal places, so 35.48. We don't need to round up that 8 because the next number is a 4. And we should check it at the end. It's an average, so it should be somewhere between 35 and 37, which it is, 35.48. And it should be nearer to 35 because we've got more of that type of chlorine atom, and it is. In this question, you're asked to show the dot and cross diagram to show the bonding in a molecule of chlorine, Cl2. So what I say to my students is, first of all, do a quick sketch underneath and then we can work it out. So chlorine is in group 7, so in this outer shell, which is the only one we're showing, there should be 7 electrons. So let's put those electrons on, at the moment, not in the sharing zone here. That's got 7 of its own electrons. We'll draw this one in dots, which also has 7 of its own electrons because it's in group 7. So we can see each atom needs 1 more electron. So this chlorine atom needs 1 more electron, so let's move one of these round to there. This is sharing 1 electron with that atom, so this atom shares 1 back. So let's move this one round into the sharing zone. Let's check. 2, 4, 6, 8, that's now got a full outer shell. 2, 4, 6, 8, that's now got a full outer shell. And each one's still only got 7 of its own. So this has got 7 crosses, this has got 7 dots. This is why I do the shuffle round method, so we don't end up drawing more electrons that shouldn't be there. So now we've worked it out, we could draw it neatly up here. And we're going to cross out our working out so we know the examiner needs to mark this one. During electrolysis, ions are discharged at the electrodes to produce elements. A student investigates the electrolysis of sodium chloride. Why does sodium chloride not conduct electricity? And that's because the ions are not free to move. Remember, in an ionic solid, the ions are all held in place by those strong electrostatic forces, so they're in a regular pattern like this in a giant ionic lattice, so the ions cannot move around when they're in a solid. Sodium chloride solution conducts electricity. Complete the sentence. Sodium chloride also conducts electricity when molten. So in other words, ionic substances conduct electricity when those ions can move when it's some form of liquid, either a solution or you've melted it. This diagram shows the apparatus for the electrolysis of sodium chloride solution. So we've got some electrodes that have been placed in the sodium chloride solution, and that's attached to a power supply by some wires. Suggest an element that could be used to make the inert electrodes. Well, they're usually made from carbon, because carbon is inert, it's not going to react with anything else that's going on, and carbon has those delocalized electrons when it's in the form of graphite, so it will conduct electricity. Complete the half equation. Well, I'm going to do this in 2 stages. We must remember that in electrolysis, ions turn into atoms. So a chloride ion is going to change into a chlorine atom. And we've got one electron to put somewhere. Do we put it on the left or on the right? If we put the electron on the left, it wouldn't be balanced because we've now got 2 negatives on the left, no negatives on the right. So let's try it on the right. If we put the electron over here, we've got 1 negative on the left, 1 negative on the right. That's now balanced. The only other thing we need to remember is that chlorine is a halogen, so it goes round in pairs. It forms diatomic molecules. So if we're going to form molecules like that, we need to start off with 2 lots of that, and we'll also have 2 electrons left over. So once we've done the working out part, I would cross that out, and there's your answer. Sodium chloride solution has a pH of 7. During the electrolysis of sodium chloride solution, hydrogen gas is produced at the negative electrode and the pH of the solution increases. Explain why. So the first thing I would do is a quick sketch like this with the positive anode and the negative cathode. Now sodium chloride will be made of Na plus ions because it's in group 1, so sodium makes 1 plus ions. Chlorine is in group 7, so chloride ion would be 1 minus. But it's in solution, it's dissolved in water. So the water molecules also break down to produce H plus ions and hydroxide ions. So in our answer, we're going to say the water part produces H plus and OH minus ions. Sodium chloride has Na plus and Cl minus ions. The negative electrode is going to attract the positive ions because opposite charges attract. So the negative electrode attracts Na plus and H plus. But which one will turn into atoms and be discharged? And the rule at this side is it's the least reactive one that is discharged. So hydrogen ions turn into hydrogen atoms as hydrogen is less reactive than sodium. So if we've got hydrogen ions turning into atoms, that means the hydrogen ion concentration decreases. We've got less hydrogen ions left behind, and it's those that cause something to be acid. So if we've got less hydrogen ions, it's going to be less acidic, so the pH increases. Acids react with some metals to produce soluble salts. A student adds magnesium to hydrochloric acid until no more acid reacts and excess magnesium remains. The equation is as follows. And then it's asking, describe how we can get solid magnesium chloride from the reaction mixture. Well, first of all, we've got to realise it's making magnesium chloride solution, AQ. Hydrogen is a gas, so that will just bubble off into the air. But we've also got some excess magnesium, which is a solid, because they've deliberately put too much in. So first of all, we need to filter the excess magnesium, and then we need to get the magnesium chloride from the solution, so we need to get rid of the water. So we need to do crystallization, or you could say evaporate the water from the solution. The reaction between magnesium and hydrochloric acid is a redox reaction. That means reduction and oxidation is going on. Explain what happens to the magnesium atoms in this reaction. Well, the easiest thing to do is to draw a magnesium atom. On the periodic table, it's got an atomic number of 12, so that tells us it's got 12 electrons. So 2 on the first shell, 8 on the next, and that means it's got 2 on the outer shell. Once we've done that, we can see that magnesium is going to lose these 2 outer shell electrons when it reacts. So the first thing we'll say is it loses 2 electrons. And then we need to remember the little mnemonic oil rig, which stands for oxidation is loss of electrons, reduction is gain of electrons. If it's losing 2 electrons, that means it's oxidation. Oxidation is loss. So we're going to say it is oxidized. Now with your science exams, they are designed to have easier questions at the start and get progressively more challenging as you go through. So we're getting towards the back end of the paper now, so no surprise we come across quite a tricky question. So it's asking us about 0.72 grams of magnesium reacting with 100 centimeters cubed of hydrochloric acid, and it's asking us to calculate the concentration of magnesium chloride solution produced in grams per dm cubed if we start off with this much magnesium. So the first thing I'm going to do actually is to copy the equation over from the previous page. We've got magnesium reacting with hydrochloric acid to make magnesium chloride solution and hydrogen. And we're told in the question we've got 0.72 grams of magnesium. Now what we've got to realise is we want to work out how much of this is being made and the concentration in particular. So we first of all say that if we have 1 mole of magnesium, we make 1 mole of this because it's the same ratio. There's no balancing numbers. 1 of this makes 1 of that. So how many moles of this have we got? So moles of magnesium equals mass over AR, which is going to be 0.72 grams divided by 24, which is the relative atomic mass of magnesium, and that comes to 0.03 moles. So we know we've got 0.03 moles of magnesium. We said before, if we've got 0.03 moles of magnesium, we're now going to have 0.03 moles of this, because what we said before was it's an equal ratio, 1 mole, 1 mole, so 10 moles, 10 moles. So if we've got 0.03 moles, we'll make 0.03 moles of magnesium chloride. Then we have to change that into a mass. So the mass of magnesium chloride made is moles times mR, which is going to be 0.03 times 95, which is 2.85 grams. So we've made 2.85 grams of magnesium chloride from the 0.72 grams of magnesium, but it's asking for the concentration, so we need to remember that equation for concentration again. You can see it's an important one. Concentration equals mass in grams divided by the volume in dm cubed. So the mass in grams is 2.85 grams divided by the volume in dm cubed. But we've got 100 cm cubed of liquid with the acid that's reacted with it. So 100 centimeters cubed, we have to divide it by 1,000 to get it in dm cubed. So that becomes 0.1 dm cubed. And when we do that, we get 28.5, and that's going to be grams slash dm cubed, which it is. If you're finding this video useful, please do hit the like button for me. Question 7. This question is about structure and properties. Which pair of substances both contain atoms in hexagonal rings? Though that's going to be fullerenes and graphene. Explain why the structure of copper allows the conduction of thermal energy. Well, first of all, we need to say it has delocalized electrons. And we need to make the point that they can move through the whole structure. So we'll say that can move through the whole metal, and it's conducting thermal energy. So when they move through the whole metal, they transfer thermal energy. Explain why copper oxide has a high melting point. Well, we need to realise that it's an ionic substance made of ions because we've got a metal and a non-metal. So we can say it's got strong forces, that's why it's got a high melting point, and they're electrostatic forces. So strong electrostatic forces, they're the forces between positives and negatives. So we'll say strong electrostatic forces between positive and negative ions, and they're going to take a lot of energy to overcome those forces. So we'll say which need a lot of energy to overcome. Explain why water, H2O, has a low melting point. Well, quick reminder, water is a good example of a simple molecule, which is just a few non-metal atoms bonded together by covalent bonding into small molecules like this. And the important thing we need to remember about these small simple molecules is they have weak forces between the molecules. We call those intermolecular forces between the molecules. So we're going to say it has weak intermolecular forces. That would get you 2 marks, one for saying weak and one for saying intermolecular. And we need to say that they don't take much energy to break those forces. So weak intermolecular forces that don't need much energy to overcome them or break them. If you found this video useful, don't forget to subscribe and check out my other videos for all the other topics of GCSE chemistry.